Hello friends, welcome to M for Mathematics. This is Kamal. In the previous video we discussed about remainder theorem. Now we will be moving towards one more important theorem, that is known as factor theorem. But before that we'll discuss one example. It says that check whether the polynomial qt is equal to 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1, or in other words we can say that 2t plus 1 is a factor of 4t cube plus 4t square minus t minus 1. Now to check this we will take help from remainder theorem. Suppose this 2t plus 1 is dividing this given polynomial. For this we can find its remainder by using remainder theorem. Okay, so remainder will be given by q minus half. Why we are putting minus half? Because if you check that 2t plus 1, we are dividing by 2t plus 1, so put that equal to 0, it will give you t is equals to minus half. So now to find remainder, what we'll do, we'll put t is equals to minus half in this given expression, in this given polynomial. So it is 4 times minus half cube plus 4 times minus half square. In place of t we are putting minus half. It will become 4 into minus 1 upon 8 plus 4 into 1 upon 4 minus minus plus half minus 1. So it will become minus half plus 1 plus half minus 1. Everything will be cancelled out. We are left with only 0. So it means remainder is coming in 0. It means we can say that 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1, because remainder is 0, it means it is divisible by 2t plus 1, or in the other words we can say that 2t plus 1 is a factor of this given polynomial qt. So it shows that 2t plus 1 is a factor of this. Now we'll move towards the statement of factor theorem. Now the factor theorem, it states that if px is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of px if pa is equals to 0. This is the same statement that we have done in the previous example, in which we have showed that q at minus half is coming as 0, right? Or this statement can be written as that pa is equals to 0 if x minus a is a factor of px. So in both ways we can check this factor theorem. Now we'll do one example based on this factor theorem. It says that examine whether x plus 2 is a factor of this polynomial or not. For that we are checking for x plus 2. So first put this equals to 0. It will give you x is equals to minus 2. So now we'll find the remainder. So this expression is px. So in place of x put minus 2. It comes as minus 2 cube, 3 into minus 2 square plus 5 into minus 2 plus 6. What is minus 2 cube? It is minus 8 plus minus 2 square is 4 into 3, 12 minus 10 plus 6. So it is coming as 18 minus 18, that is 0. So it means x plus 2 is a factor of given polynomial, that is x cube plus 3x square plus 5x plus 6. This is how we are going to use this factor theorem. Now we'll do one more example based on factor theorem. Find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. So now it is given that x minus 1 is a factor of this. So as per the statement, if x minus a is a factor of px, then pa is equals to 0. So we'll write like this as x minus 1 is a factor of this given polynomial, say px. So p1, why 1? Because x minus 1, putting this equals to 0, you will get x is equals to 1. So we'll check for p1. So as it is a factor of px, so p1 will be 0 as per the statement. So this means 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k equal to 0. What we are doing? We are putting x is equals to 1 in this polynomial. It comes as 4 plus 3 minus 4 plus k equal to 0. 4 and 4 get cancelled. So it means k is coming as minus 3. So value of k will be minus 3. This is how we are going to use this factor theorem. Now, the next topic is factorization of ax square plus bx plus c by splitting the middle term. To factorize ax square plus bx plus c, we have to write b as the sum of two numbers whose product is AC. We'll check this with help of one example. Factorize 6x square plus 17x plus 5. We'll factorize this expression by splitting the midterm. So midterm is 17. How to start? Find the product of 6 into 5. 6 into 5 is 30. Now we'll factorize 30 such that we'll find two factors whose sum is 17. So 30 is 15 into 2, and if we add 15 and 2 we are getting 17. So we'll write this 17 as 15 plus 2. This you can check that product of 15 and 2 is 30 and their sum is 17. This is how we are splitting the midterm. Now this 15 into x is 15x plus 2x plus 5. In these two, 3x is common in these two. So it will become 2x plus 5. In these two, nothing is common, so it means 1 will be there. So we'll take 1 common, it will become 2x plus 5 only. Now in these two, 2x plus 5 is common, so just pull this out and we are left with 3x plus 1. So these are the two factors of this 6x square plus 17x plus 5, and this method is known as splitting the middle term. Now the same question, factorize 6x square plus 17x plus 5 by factor theorem. Earlier we have done it by using splitting the midterm. Now we'll do the same question by using factor theorem. For that, first of all we'll make this coefficient of x square as 1. For that we need to take this 6 common. It will become x square plus 17 upon 6x plus 5 upon 6. This method is little lengthy and little bit tough, so just watch it carefully how to do this. So we need to concentrate on this number, that is the term without x, without variable, that is 5 by 6, and we'll factorize it. Write all the possible factors of 5 upon 6. So these are, we can start with plus minus 1, plus minus 1 by 2, plus minus 5 upon 3, plus minus 1 upon 3, plus minus 5 upon 2, plus minus 1 upon 6, etc. So write all the factors which are possible factors of 5 upon 6. So now as per the factor theorem, if these are all the factors, so what we have to do, we'll put one by one all the numbers in this expression and check for which number is giving you 0. So I'm starting with one number. Randomly you can check anyone. I'm putting minus half in this. We'll check whether it is coming as 0 or not. minus half square is 1 by 4 minus 17 upon 12 plus 5 upon 6. What is your LCM? LCM of 4, 6 and 12 is 12 only. It is 3 minus 17 plus 10. It's not coming equal to 0. Check for another one. So I'm putting in place of x minus 1 by 3 now. So it will become minus 1 upon 3 square plus 17 upon 6 times minus 1 upon 3 plus 5 upon 6. It is 1 upon 9 minus 17 upon 18 plus 5 upon 6. LCM of 9, 6 and 18 is 18 only. It is 2 minus 17 plus 15, which is 17 minus 17 upon 18. It is coming as 0. It means x is equals to minus 1 by 3 is satisfying this expression. It is coming as 0. It means that x plus 1 by 3 is a factor of this expression. Now we'll check with another number, say minus 5 by 2. Now in place of x, put minus 5 by 2. We are checking whether it is coming as 0 or not. 17 into 5 is 85 upon 12 plus 5 upon 6. LCM will be 12 only. So it will become 75 minus 85 plus 10. 75 and 10 is 85. 85 minus 85 is 0. So it is coming as 0. It means on putting x is equals to minus 5 by 2, we are getting 0. So x plus 5 by 2 is a factor of this expression. So now we have both the factors. It means we can write this expression as now with help of these two factors, that is x plus 1 by 3 and x plus 5 by 2. So just take their LCMs. It will become 3x plus 1 upon 3 and 2x plus 5 upon 2. 3 2s are 6. It is cancelled out. So these are the two factors of given expression, that is 6x square plus 17x plus 5. This is your answer. This is how we can use factor theorem to factorize one given expression. Now we'll take one more example. This is the quadratic one, and now I'm taking one example which is a cubic expression. How to factorize a cubic expression by using factor theorem. Now look at this example. Factorize x cube minus 23x square plus 142x minus 120. We'll use factor theorem to solve this. So I'm considering it as px. So what is the constant term here? That is 120. So what we'll do, we'll factorize 120. We'll try to write all the factors of 120. So start with 1. So I'm not writing all the factors, I'm just noting down some of the factors. Rest you can do by your own. There are many factors. Okay, so write all. We can check one by one with all the factors. So I'm starting with 1. Okay. So first I'm putting x is equals to 1. So we'll find P1. Let us check whether we are getting 0 or not. It is 1 minus 23 plus 142 minus 120. So it is coming as 0. Right. So we are the lucky one that we are getting in the very first step as 0. So it means P1 is equals to 0, which says that x minus 1 is a factor of px. Now once we are getting one factor, we can find rest of the factors by using simple division method. Okay, so now we can divide this expression, this cubic expression, by x minus 1 to find other factors, or we can continue with the process by putting 2, 3, 4 and so on. It's up to us how we are going to use. So, and there's one more way, like it is a cubic expression. So this is direct division method, we can say. So I'm writing this x minus 1 3 times here, because it's a cubic expression, so I'm writing it x minus 1 3 times. Now look at this. What is my first thing? My first term is x cube. So I need to multiply this by x square. So it will give you x square into x cube. Now I'm having 23, minus 23x square, and here I'm getting minus 1x square. So how many are left? Minus 22. So I'm putting minus 22x here. So this will give me a minus 22x into x, minus 22x square. 1 minus x square is coming from here, so it is making it minus 23x square. Now this minus 22x will multiply with minus 1, so it will give you plus 22x. Whereas we are having 142x. So how many are left? 120. So I need to multiply this by 120. So in these three, x minus 1 is common, and I'm getting now x square minus 22x plus 120. Now this is one quadratic expression, and I know how to solve it by using splitting the midterm. So that we can do by using splitting the midterm. So factors of 120 which on addition or their sum is 22. We need to find two factors of 120 whose sum is 22. So these are 12 and 10. 12 into 10 is 120, and 12 and 10, their sum is 22. So what I'm doing now, I'm splitting 22 as 12 and 10. It becomes minus 12x minus 10x plus 120. In these two x is common, so take this out. In these two 10 is common. X minus 12 is common in both. So these are the three factors of this given cubic expression, x cube minus 23x square plus 142x minus 120. If this division or this way is not clear, in place of this you can use simple division. Just divide this. If you're comfortable with this, you can opt this method as well. If not, just do the simple division. Right? This is x. Here we have x cube, so we need to multiply it by x square. So it will give you x cube minus x square. Subtract, x cube got cancelled. It is minus 22x square plus 142x minus 120. Now what is required? Minus 22x square. So we need to multiply it by minus 22x, which comes as minus 22x square plus 22x. Subtract. 142 minus 22 will become 120x minus 120 as it is. Now what is required? 120x, and this is x. So we need to multiply it by 120. So it will give you 120x minus 120. Subtract them, cancel out 0. So this factor is coming as the quotient, right? And rest is like this only. So this is how we are going to use factor theorem to factorize a cubic polynomial. This is all about factorization, factor theorem. In next video, we'll be discussing about algebraic identities. Keep watching M for Mathematics. Thank you.